Welcome back to Zero Dark Emissions. Last time we left off with the installation of the rear motor in Gearbox, and in this episode we will install the front motor in Gearbox. The front has some basic differences from the rear. First, as already mentioned, the idea will be to only run the front motor when in four-wheel drive. Instead of a transfer case, our change from two-wheel drive to four-wheel drive will be handled by turning on and engaging the front motor, and this means not only turning the motor and inverter on and off between two-wheel drive and four-wheel drive, but also physically connecting and disconnecting the drive. The reason that we want to physically disconnect the drive is that without the disconnection, the motor would be turned by the front wheels as the vehicle moves forward, and this would mean that it would turn our motor into a generator, where the electrical energy generated would want to be backfed into the batteries. Feeding electrical energy into the battery in and of itself is not a bad thing, and in fact that is what will happen with the motor or motors that are engaged when we take our foot off of the accelerator. We will get some free electricity via the momentum of the vehicle as we are slowing down. However, this is not good from the standpoint of a motor that is not engaged for two reasons. First, the energy that is backfed into the batteries would be less than the energy used by the rear motor to overcome the frictional loss at the front. So this would be a net loss and just be a drag on efficiency and would create undue wear on the motor. Second, when the motor is not engaged, the contactors that power this from the batteries are open, meaning that there is no connection to the batteries for this energy to pass to the batteries. We will get into more detail about the high voltage circuiting, including the contactors, in a future episode where this will become more clear. In order to accomplish the disconnect, I will be using a Remco drive disconnect by Superior Driveline. This disconnect is more typically used to disconnect the drive on vehicles that are being towed behind an RV, for example. The disconnect has a sliding collar that engages and disengages the opposing gear teeth on either side. Normally, this drive disconnect would be welded to a drive shaft of an appropriate length for a specific vehicle, but in my case, I want this attached to the slip that is inserted into my gearbox. So after discussing with the good folks at Superior Driveline, I was able to ship them my slip yoke for the gearbox, and they were then able to remove the ears on the slip yoke and weld the remaining slip shaft onto the disconnect. Now I have my connection between the gearbox and the U-joint at the diff with a disconnect between them. The disconnect is a very well-made, solid component that I am really happy with. The collar shifts very smoothly and locks into both positions via internal ball bearings on springs. One little thing that I did need to modify on this part was machining out the missing gear slots that are 180 degrees apart on the disconnect. These missing gear slots are there for the normal application of this disconnect, where you have a yoke on the opposite end of the drive shaft that this would be connected to. This forces the yoke at the disconnect to stay in phase with the yoke at the other end of the drive shaft. But I do not have this condition, and I want to make a smoother shift into four-wheel drive where I do not have to have these missing gears line up. So Superior was able to remove these blanks. Normally the collar that slides back and forth would be controlled via a cable and pull handle, but I will be using an actuator that slides this back and forth when shifting between two-wheel drive and four-wheel drive. The switching that controls this actuator was previously covered in episode 9, and the installation of the actuator itself will be covered in a future episode. One other little thing regarding the connection at the front. Although my Humvee originally had a 1330 yoke at the rear, which I kept, it had a 1310 yoke at the front. Not really sure why. So I opted to change this out for a 1330 for consistency with the rear, and the Remco disconnect yoke is a 1330 to match. The second difference at the front is that it will be partially located below a new platform that will support the secondary battery control box and inverters. Since we will be using the existing engine mount bolt locations to support both the platform on this end as well as the motor mounts on this side, we will need to install the platform supports along with the motor mounts. Here you can see the platform, and here are the supports for the platform at the back end, which will share the same bolts with the motor mounts. Note that these are slightly different from each other, not only in that they are mirrored from each other, but also have different mounting hole locations that match the original motor mount bolt locations at each side. The one at the passenger side also has the bolt locations for the body mount bracket in this area. One other difference with the brackets on this side is that they need to be welded to plates that have the correct bolt hole locations that match the existing locations, and place the brackets in the correct locations for the motor mounts. The motor mount brackets on the opposite side of the motor will utilize new holes with tubing welded in as with the rear. Note that I am locating these mounts lower on the face of the chassis rail rather than centered. This is due to the fact that one of the cooling lines from the main battery box will be exiting the box in this area, and moving the mount lower avoids a potential conflict between the two. I actually installed these mounting holes at the same time that I did the ones at the rear. As with the rear, we can now install all 4 motor mount brackets along with the platform supports in order to give us good final measurements of the bushing locations relative to the U-joint connection in all directions. As with the rear, we are placing these brackets with 1/8 shims to give us some tolerance for the final installation and are installing centered in the elongated holes. The actual motor mount plates at the front are very similar to the rear, utilizing the same 1/4 inch thick steel plate connected to bushings that attach to the same brackets at the chassis. With the motor mount parts delivered, we can now temporarily assemble everything before lifting into place. I didn't show the assembly of the motor and gearbox in the last episode, so I'll show that here. I am first lifting the motor up onto a makeshift platform on top of the lift legs so that I have adequate room to assemble the motor and gearbox. Here you can see the adapter plate, as well as the spline shaft, both of which marry up to my motor and came with the torque box. As mentioned last time, we are using the same bolt locations that attach the gearbox to the motor to connect the mount. I am using new longer bolts than the ones delivered with the gearbox to account for the extra thickness of the mount plate. You can see here where we have a space in this recess in the adapter plate. For the final installation, we will place steel spacers in here, but not needed now for the temp install. This next sequence is repetitive from the rear, and I'll just give you a quick time lapse. Unlike the rear, we will place the motor and gearbox with the slip yoke, including the U-joint, installed at the gearbox. At the rear, it was easier to install the flange yoke with the U-joint at the differential output, and then marry the gearbox flange output to the flange yoke. But with the slip yoke at the front, it is easier to handle it this way. Note that the main thing at this stage of tack welding the motor mounts to the bushing housings is aligning the motor mounts to the bushings in the longitudinal direction. The cross-sectional direction is handled via the shims and not critical to the tack welding, which just wants to have the bushing housings fitted tightly to the motor mounts. One other thing that I did not mention last time is that I am installing the motor and gearbox with the bushing brackets installed on the motor mounts rather than on the frame. I find it a little easier to install it this way rather than feeding the bushing housings into the brackets on the frame. Another important item is that I am making sure that the gearbox output is spinning freely after I tighten each bolt to ensure that I am not applying any pressure on the gearbox output and creating a bind. At the rear, I needed to not only do this at each of the 4 bushing mounts, which account for 2 directions, up and down and side to side and cross section, but also in the longitudinal direction since we do not have a slip like we do at the front. So at the rear, I needed to play with the number and thickness of shims to get it just right. The side to side is not as critical since we have elongated holes in this direction. We just need to make sure that the bracket shims put us within the range of the elongated holes. Here you can see where we added the steel spacers to account for the recess in the gearbox adapter plate. I had to do this with 2 pieces since the overall thickness was too thick to laser cut without overheating with this small part. One thing that I did not mention in the last episode is the need to align the Zerk fittings at the bushing housings prior to tack welding. These Zerk fitting holes want to be located at the bottom where they will be easily accessible, but away from the motor mount welds. One last thing is to get the vent lines installed at both the front and rear. Note that I did part of this ahead of time before installing the motors, along with the localized brake lines in these areas, and then after the motors were installed I modified it slightly to configure better with the vent locations on the motors and gearboxes and make the final connections. Note that the vent lines for the motors and gearboxes are larger than the ones for the diffs and geared hubs, so I placed a brass reducer fitting to transition between the lines coming off of the diffs and geared hubs to the ones for the motors and gearboxes. We will wait until we get further along to complete the vent lines to their termination point at the front. With both the front and rear motors and gearboxes installed, we can now confirm the amount of space left for our main battery box, which will live in between this equipment. We are about 3/4 of an inch shorter than what we were anticipating. I could have and should have shifted the front motor a little more forward on the bushing mounts, but this is still workable. So next time we will cover the fabrication and installation of the main battery box. See you next time.